Hello students, uh, this particular video is about corrosion and a few topics about the how we can apply this particular chapter, chemical equations and chemical reactions, where it is applicable in our world today. Okay, one of the most important phenomenon that takes place is corrosion. Okay, and as I told you, everything around us in our whole world, in the whole universe, there are a lot of chemical reactions that are taking place. There are chemical changes that are taking place, and one of them is corrosion. Okay, and this is the definition for corrosion. Corrosion is defined as when a refined metal is naturally converted into a more stable form, such as its oxides, hydroxides, or sulfide state. This leads to deterioration of the material. I hope I've made a little bit of meaning to this particular definition. Is okay. What is the meaning of this? A corrosion is where a metal is involved. So please remember, metals get corroded. It undergoes corrosion. Why do they do that? Because they want to form a stable compound. And what is a stable compound that it forms? It forms a stable compound of its oxide or hydroxide or sulfide, and this will lead to a deterioration of the material. Okay, so this is the meaning of corrosion. I hope you've understood the definition. The metal is getting corroded, okay, in a stable form, but it is not good for the metal itself. Okay, the metal becomes deteriorated, and this is corrosion. So I hope you've understood the definition. Now, what is the causes of corrosion? How does it happen? Okay, when the metal reacts with gases like hydrogen and oxygen, then you can see corrosion takes place. In the presence of electric current, then again you see corrosion can take place. And if there is dirt that is present over there, then corrosion takes place. If bacteria is present, then you have corrosion taking place. And also if there is stress that is applied to a particular element or a particular situation, a stress also results in corrosion. So going back to this points again, we have 5 reasons why corrosion takes place. These are the causes. 1, reacting with gases like hydrogen and oxygen, electric current, dirt, bacteria, and stress. Please remember, these are the causes for corrosion. Okay. Now, how will we be able to see corrosion taking place in iron? Okay, iron. How does iron corrode? Like all of us know that we have many articles in our house that is made up of iron, and you see that it can get corroded. Okay, you will be able to see some kind of a film that is on top of iron, and then you see that that iron metal is not of its utmost use. So you see that corrosion takes place. Now, how does this happen? Okay, the most important type of iron corrosion is taking place because of the presence of 2 elements. What is that? Oxygen and water. Okay, the most important thing that happens when corrosion takes place is it is because of the presence of oxygen and the presence of water. So what happens then? Iron, when a red iron, okay, when red iron, hot iron, okay, you have that iron there, and it reacts with oxygen and water. So you saw the reaction over here. This is the iron. Okay, it was nice here. You saw how the metal is lustrous metal. Okay, gray, silvery, white metal over here. Now, what happened over there? There is a brown color substance. This brown color substance has come because of what? Because of oxygen and water. Okay, when iron reacts with oxygen and water, what is formed? Rust is formed. Hydrated iron oxide is formed. Okay, where iron's valency is 3 and oxygen's valency is 2, you balance the equation and you get Fe2O3, dot XH2O. The number X over here denotes the number of molecules of water. Okay, and this is how rust is formed. There is a question that can be asked, what is the formula for rust? You have to answer it as Fe2O3.XH2O is the formula for rust. And in this case, when you have the equation, the balanced equation is 4Fe plus 3O2 plus 2H2O, giving you 2Fe2O3.XH2O. So this is the formula for rust. Okay, so please remember, here also you have got this reaction here, Fe2 ion, known as rust. Okay, in the solid form. Okay, here you have dot molecules of water. So this is rusting. It is also called as rust. Okay, and it is called as corrosion. Okay, what is the metal used here? Iron. And it undergoes corrosion because of oxygen and water and formation of hydrated iron oxide, which is called as rust. I hope all of you have understood this phenomenon called corrosion. Okay. I would like you all to, we want to prevent rusting. We don't want corrosion to take place because it degrades our metal. So we need to prevent and treat it. How do we prevent it? Have you got any ideas of how should we do it? Okay, how should we prevent it? Have you seen your parents, in order to see that particular instrument that is made up of iron is not corroded, they'll sometimes use oil, they'll put oil on it or grease on it. And there are many ways by which we will be able to prevent and treat and see that metals are not corroded. Okay, I'll show you in this particular video how it will be done.
Let's think about cars for a moment. The car that you've had in mind was likely painted with your favorite color. The paint is not only there to make your car look pretty, but it has a more important purpose, to prevent rusting. When iron and steel are exposed to oxygen and moisture, rusting will occur. Rusting describes the corrosion of iron and steel. The term corrosion is used to describe the breakdown of a metal when exposed to the environment. When we say a metal corrodes, we mean that it has reacted with water and oxygen from the environment to form their respective oxides. We can demonstrate this using a simple experiment. Place an iron nail in 4 test tubes. Fill one with regular tap water until the nail is submerged. Fill another with regular tap water and add half a spoonful of sodium chloride, regular table salt. Shake from side to side to ensure that sodium chloride fully dissolves. Fill the 3rd test tube with recently boiled water and add a thin layer of oil. When we boil the water, we remove any dissolved oxygen, and the layer of oil prevents any oxygen from further dissolving. In the last test tube, add a spoonful of calcium chloride. Calcium chloride removes moisture or water. So in the first test tube, the nail is exposed to oxygen and moisture. In the second test tube, the nail is exposed to oxygen, moisture, and salt. So in the third test tube, the nail is only exposed to water. In the fourth test tube, the nail is exposed only to oxygen. Stopper all 4 test tubes with a rubber bung and let stand for a couple of days. You will find that the nails in the first and second test tubes have rusted. In particular, the nail in the second test tube has rusted more than the nail in the first test tube, and the rust has likely flaked off. You may see a reddish-brown precipitate at the bottom of these tubes. The nails in the third and fourth test tubes have not rusted. So what has happened here? The iron has undergone an oxidation reaction, forming hydrated iron trioxide or rust. Salt and acid act as a catalyst for this reaction, which is why the nail in the second test tube formed more rust than the nail in the first test tube. Rusting can be very costly if we have to constantly replace these items made of iron and steel. Rust can be prevented if we paint the areas exposed to oxygen and moisture. This is done on many bicycles and cars. Another method to prevent rust is by placing a layer of oil or grease. This is done on many bicycle chains. It helps lubricate the moving parts, which reduces friction and slows down the rusting process. Another way to prevent rusting is a sacrificial protection method called galvanizing. Have a look at this reactivity table. Zinc is more reactive than iron. When exposed to oxygen and moisture, zinc will corrode faster than iron. So if we put them together, zinc protects iron but is sacrificing itself, hence the term sacrificial protection. This method is applied to prevent rusting on ships. The oxidation of zinc can be described using this following equation. So besides preventing rusting, there is another advantage to this galvanizing process. The formed zinc oxide layer can be removed, and the freshly exposed zinc can corrode once again, thereby further protecting the iron or steel hull.
I hope all of you have understood this particular video. It was very well explained. I'm sure all of you have understood this video, and you have got the understanding how, is rusting taking place, okay, and how we will be able to prevent it. It was a very nice video. I'm sure all of you have understood the process, okay, where rusting takes place in the presence of oxygen and water, as well as we have also seen that we need to see that oxygen is not present, and we also should see that there is no water vapor over there. Also, water also should not be present there, and in order to do that, we'll have to be able to see that water is removed. We can put calcium chloride salt over there so that it can remove the water. Okay, you can put a little bit of grease there so that we will be able to not have the oxygen content over there. Okay, boil the water so that the oxygen will not be present over there. So if you do these things, you will see that you're removing oxygen and you're removing the water vapors, and then what will happen to your iron? They will not be able to undergo rusting. But the most important point is that we can see that we'll be able to put paint, simple ones. You can paint it. Many of you can see that painting you'll put on your cycles, or in some of your instruments you put paint. Paint will also to an extent will stop corrosion. But here we saw a very important topic called galvanization, where we will be able to paint the iron metal with zinc. Okay, so zinc will be able to undergo corrosion, and what will happen? You can just remove the zinc off and your iron still stays there. So nothing has happened to your iron instrument. And so zinc will be able to be exposed to the oxidation process, and you will be able to remove that zinc oxide as flakes. And then again, you will be able to paint back your zinc, and then that particular instrument can be preserved for a longer time. So I hope you've understood that video. The next slide that we are going to talk about is rancidity. This is another example of how, again, reactions are taking place. Chemical reactions are taking place in our, surroundings. Okay, rancidity. Sometimes we have noticed that our oils, okay, if it is exposed for a long time, okay, oxidation will take place in these fats and oils that are present, and there will be a very unpleasant smell and odor, which is not good. Okay, and that is said to be rancidity. The definition goes like this: development of unpleasant smell due to oxidation of fats and oils, which are often accompanied by changes in their texture and appearance. So this is the definition of rancidity. Now, how does it happen? It is because of light, oxygen, some trace elements like iron or zinc. Okay, please remember trace elements like iron and zinc, salt, water, molds, and bacteria. These are some of the elements that causes rancidity. I'll repeat it again. Please memorize these points over here. What causes rancidity? Light, exposure to light, exposure to oxygen, exposure to the elements like trace elements like iron and zinc, and salt, water, molds, and bacteria. Okay, so this is rancidity. Okay, now look at this. Okay, these are some food that you usually eat, Lay's packets. Okay, some butter is there. Okay, all these. Okay, you can see there chicken pieces over here which is fried with oil. Okay, and that is also put over there. All these can undergo this process called rancidity. Okay, rancidity can take place because of the exposure to all the points that we have discussed. Okay, some kind of light will be exposed to it, some trace elements can be exposed to it. Okay, some algae, fungus, molds, all those things will expose, and you will get a very foul smell. Okay, so what are the things that they do in order to prevent this? Okay, so here we can see how do we prevent the chips that are there. You can see most of the packet is like very fluffed up because it is filled with nitrogen. Okay, potato chips are packed in thick foil packets that are filled with nitrogen, and nitrogen over there does not undergo oxidation. It prevents the chips from staying fresh, and it does not undergo rancidity. It can be preserved for a longer time. Okay, another way of preserving is by refrigeration. Okay, some dried items, like you have to dehydrate it without any water, and sometimes you can keep it in storage rooms. So these are some ways by which we will be able to prevent rancidity. Okay, and you can also some other ways are add some additives. For example, in some fruit products you can add sulfur dioxide, and in meat products you can add sodium or potassium salts like sodium nitrate, potassium nitrate, in order to see that this meat will be preserved for a longer time. You can also add some antimicrobial agents or antioxidants like sodium benzoate and benzoic acid. In fruit juices, you have seen fruit juices where you will be able to keep it in the fridge for a longer time and you can use it. That time you can use preservatives like the sodium benzoate and benzoic acid, propanoic acid, sodium and calcium salts, okay, in bread and cheese. So propanoic acid and sodium and calcium salt in bread and cheese also will be able to preserve it for a longer time, and it will not undergo rancidity. Okay, so some of the traditional methods that we can see in our houses, we can also do pickling and fermentation and salting and also vacuuming. So these are some of the traditional methods, okay, where we will be able to prevent from rancidity. Okay, from rancidity, we'll be able to do these traditional methods. I'd like you all to watch this particular YouTube video and see how you will be able to prevent rusting and prevent rancidity.
Rancidity. Have you ever tasted or smelt the fat or oil containing food materials which have been left for a long time unused? These fats and oils which have been left for a long time unused get oxidized and become rancid. As a result, their smell and taste also changes. This process is called rancidity. Usually substances which prevent oxidation, also called as antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers also helps in slowing down the process of oxidation. Do you know that chips manufacturers usually flush bags of chips with gases such as nitrogen so as to prevent the chips from getting oxidized?
So this was a short video where we were able to see how we will be able to prevent rancidity from taking place, so that we will be able to preserve the food items for a longer time. So I'm sure all of you have enjoyed this video and you have understood this two brief topics that is naturally happening in our surroundings: corrosion as well as rancidity. I hope you've understood it, and as you go through your books you will be able to see very clearly. You'll get these examples and you'll be able to see picturize these videos so that your class will be very good one and you will be able to understand it clearly. Thank you, students. I hope you've enjoyed the class that I have prepared for you, and all the best. I hope or you will go through your lessons well, and if there is any doubts that you have, please do not hesitate to approach your teacher, and we will be able to give you more clarification if there is any doubt. Thank you, students. I'm glad that I was able to take this class for you. Bye-bye.